In one of the earlier videos, we transformed this limit problem here into this form here. So really, in effect, these two are exactly the same, but just written differently, because we wanted to rewrite this bubble here in this form here. So this is exactly the same as this, and well, if you look at this limit here, as n increases, this bubble here will get smaller and smaller. So hang on. So looking at this bubble here and this bubble here, so your n is here. As you increase n, as n gets bigger and bigger and bigger, this bubble here will get smaller and smaller, and this one here will get bigger and bigger. And then in this case here, down here, in this case you're working in reverse now. So x is quite big, and then you decrease x. But the thing is, as you decrease x, as x gets smaller and smaller and smaller towards zero, this bubble here will get smaller. This bubble here will get smaller and smaller, and this one here, as a whole, will get bigger and bigger. The point that I'm trying to make in this video is that, well, you have to set this equals this, so that and then hang on, times hang on. At the moment, it's this equals this, times both sides by n. Hang on, so that will be 1 equals delta x times n, and then hang on, and then divide both sides by delta x. So that will give you this here, delta x equals n here. You see, looking at this n here, you have to use 1 over delta x. You have to use 1 over delta x. So this thing here is equal to this. Now, what I'm trying to make, the point I'm trying to make here is that you have to use 1 over delta x. If let's say, if you had something like this, squared, okay, delta x squared. And don't forget, if you look at it from this perspective, as x gets smaller and smaller, this thing gets smaller and smaller, and this new thing here as a whole will get bigger and bigger. You could argue that it makes sense, because this is getting smaller and smaller, and this is getting bigger and bigger. But really, you're changing things, because what's happening is that, well, if you have a squared here, then this bubble here, well, as you decrease x, as x gets smaller and smaller and smaller, this will get smaller and smaller. That's okay. But then this thing here will get bigger and bigger by a much faster rate than up here. Because hang on, if you have a square here, okay, looking at this bubble, looking at this bubble here, looking at this bubble, looking at this bubble here. If you have this square here, then look what's happening. As this one increases, this will get smaller, and this will get bigger by the same rate. But then if you have a square here, then as x gets smaller and smaller, this here will decrease, but then this here will grow by a much faster rate than up here. The point is that if you have a square here, it no longer makes sense. You're changing the whole dynamic of this block here. The two blocks are not equivalent. Okay, so you have to use 1 over delta x. Try and visualize it like this. Hang on. So times both sides by n. Okay, yeah. So you got to have this. Even if you have just a 2 over here, yes, the whole thing does get bigger. This whole bubble does get bigger, but then the rate at which it gets bigger in comparison to this one, well, it would change. Even if you have a 2 here, hang on. Even if you have a 2 here, okay. So hang on. So visualize it as this bubble here and this bubble here. Okay. Now, as x gets smaller and smaller, this here will get smaller and smaller, and then this thing here grows, but then it grows by a much faster amount than up here. You see, up here, up here, this one will get smaller and smaller, and this one will get bigger and bigger by the same rate. But then if you have a 2 here, even if you just have a 2 here, then this one will get smaller and smaller, but then this one grows. Yes, it does grow, but it grows by a much faster rate than this one here. So by you having something like this, you're really changing the whole dynamic of this block here. So you have to use 1 over delta x. Okay, even though you could argue, yes, this gets smaller and this gets bigger, just like up here. But the thing is, if you have something like this, this whole thing here will grow much faster than well, you are really changing the whole dynamic of the whole thing if you have, let's say, something like this to the power of 3, because this one here will grow much faster than this rate decreasing. Okay, so you basically if you have something like this, you're changing the whole dynamic of this whole block here. They won't be the same. Okay, so you have to use 1 over delta x.